Okay, thank you so much for joining me today. We are looking at instantaneous rate of change. Now, there's a few elements that we need to think about. So, if I have this graph, I'll take this part off. Okay, if I've got this graph here and it's y equals to the power of x, we know this is going to be exponential growth. So that just means it's going to be a curve like this. So, because if we've got 2 to the power of 0, that is going to be y equals 1. So now if I'm thinking about exponential growth, it's going to keep on going higher and steeper. Now, there's a few things we need to look at about finding instantaneous growth. Now, what we've been doing is we've been using the trying to find the average rate of growth, and we've been doing that by, if I want to find the average rate of growth for 3, I'll have 2 points next to it on either side to find that. So if I pick a point over here, I am then going to draw a line between those 2 points. So this line here is called the secant line. Now, for us to get instantaneous rate of growth or an estimate, we need to make this second point as close as possible to the 3. So if I make it as close as possible, I'll put it here, then I am going to get a more accurate picture of the rate of change. And that is how we will be able to get the instantaneous rate. Now, if we just have 1 point, we're just using this. This would be called the tangent line. But we are going to be using our understanding of the secant line to help us out. So to start off, I'm going to draw this graph again, just so it's easier for us. So I've got a lot, since I've got a lot of points on there. So I'm going to have my lovely point here, which I'm looking at, which is 3. So if I've got 3 here, I'm going to be picking a point close to it and creating a secant line between those 2 points. The closer I get, will be an approximation of the instantaneous rate of change. So if I want to find the point for 3, I also need to look at the x value close to it. So I might go 3.01. So if we are thinking about looking at rise over run, if I expand that part there, our formula for rise over run is the function of b minus the function of a, because that is our y-axis, divided by b take a. So that is our equation. Now if we can use that with these points to help us out, so let's have a go. So if I have the function of b, so that is going to mean this is b, 3.01. I'm going to plug that in to this equation and that will give me the function of b. So that just tells me that when I have an x value of 3.01, I'm going to have a y value of 2 to the power of 3.01. When I have an x value of 3, now I'm looking at a, the function would be 2 to the power of 3. 2 to the power of 3 is 2 times 2 times 2. So 2 times 2 is 4. 2 times 4 is 8. So now I have my 2 points for my equation. So I'm going to substitute them in now. So to start off, I'm going to use my function b, which is 2 to the power of 3.01 minus 8 divided by 3.01 minus 3. And we can do this because it needs to be as close as possible. We can't have a denominator of 0. Then we're looking at limits, which we will get into. So now I can go, okay, well, I'm going to use my calculator for this, but I know the bottom is 3.01 minus 3 is 0.01. So I'm going to plug this into my calculator now, and I'll spit out the answer. So 2 to the power of 3.01 minus 8 divided by 0.01, and it gives me an approximation of 5.56. So that is the approximation of my gradient, my slope, which is my instantaneous rate of change for my line at x equals 3. Really hope that helps you understand how we can work out the instantaneous rate of change. Also understanding a secant line and a tangent line.